Hello everyone, I'm Zu-Ming Jiang from ETH Zurich. I'm happy to be here to present our work on finding deep bugs in database system using complex and valid queries. This is a joint work with Jia-Ju from Tsinghua University and Zhendong from ETH Zurich. This work is about testing database systems. So what is a database system? Some of them are very famous, like MySQL, SQLite, and PostgreSQL. Maybe some of you have been using them. I think the database system is the system that used to efficiently manipulate data. So database systems actually are widely used everywhere in the world. For example, operating systems like Windows and Linux and web browser, television, airline, and car, even in each smartphone, they are relying on database system to process data efficiently. So the bugs in database system can be very critical because the bugs affect not only the database system itself, but also all the downstream application relying on the database. So it's very important to detect database bug. Many database systems take as input the scripts written in structured query language, that is SQL query. The database system need to process this query by syntactically and semantically check their grammar and structure. And then the database system will try to optimize this query, generate several query plans, and evaluate them, and finally execute the most efficient query plan. To detect bugs in database system, we need to pass the syntactic check and the semantic check, and then we can find bugs in later process. Suppose we want to test database system with valid but simple SQL query. Yes, of course, this query can easily pass the syntactic check and the semantic check. However, because this query is very simple, it could not trigger the deep logic of this database system, so they will miss bugs, especially the deep bugs in the optimization or evaluation part of the database system. So what if we want to try to generate complex query? When the query becomes complex, the query easily become invalid because just one syntactic error or semantic error will make the whole query become invalid. If the query is invalid, it will be discussed in earlier stage, no matter how complex it is. So ideally, we want to generate complex and valid SQL query to test database system. In this case, we can test the database system more thoroughly and find deep bugs. But apparently, it's very challenging and very difficult to generate such complex and valid SQL query. The challenge comes from the fact that complex queries are difficult to statically model. For example, this is a query generated by our approach which can crash the MariaDB server. You can see that in the second SQL statement, it uses a 3 sub-level select statement to construct a view. And then this view actually are used in the third statement. So there is a complex data dependency between the third statement and the second statement. To generate such query, we need to accurately infer the attribute of the generated view. However, it's very difficult and error-prone because the view is very complex. If we incorrectly infer its attribute, we cannot reference it correctly. And finally, we will generate invalid query. To solve this challenge, our idea is instead of statically infer the attribute of the generated variable of database, we could dynamically collect the database state information from the database engine. For example, we still use this as example. After executing the first SQL statement, the database state stored in the database system will contain the one table and its and its attribute. And then we can use this information to construct the second statement. After execute the second statement, the database system actually will update the database state, and then it will add additional view here and then record its attribute. So we can use the recorded information in the third statement. This database information are actually very easily can be collected by the in the database schema. For example, we can use this 3 SQL statement to collect the database information like the table name and the view name and their attribute like the column. So based on this idea, we implement our approach, dynamic query interaction. In this approach, we first query the database state in the database system, and then we use the database state to generate our SQL statement. And then we send this SQL statement to the database system, let the system execute the statement. And then we check the database system's status. If the database system crash, we record it as a bug. Otherwise, we let it query the database state again. We could use this, take it as example, how we generate the example bug triggering query in the beginning of this presentation. First, we query the database state from the database system, and then it returns empty because no statement are executed before. And then we generate the first one, create a table statement. We send this statement to the database system. It executes it, and then everything is fine. Okay, we enter the next round. In the second round, we query the state again, and then this time it returns a set containing a table. We use this database state information to generate another statement, and then we send this statement to the database system again. Everything is fine, still fine, so we enter the third round. In the third round, we query again, and then this time the database system returns a set additionally contained a view, and its attribute is C2 and C4. Based on this information, we can construct the third SQL statement. We send this SQL statement to the database system again, and this time, this database system crashed. So we find the bug, and then we record it as a bug report and record the malicious query containing the bug triggering statement and the statement executed before the crash. By using this approach, we have found 40 bugs in 6 popular database systems like MySQL, MariaDB, PostgreSQLite, and MonetDB, and ClickHouse. Among these 40 found bugs, 19 of them have been assigned CVEs. We tried to analyze this, the bug triggering queue rate of these bugs, and found that most of the bugs can be triggered only when the query contains more than 3 or 4 statements. And then we also analyzed the size of the bug triggering query. We found that as the size increase, we can find more bugs in database system. We also analyzed the query we generated. 78% of the generated query are valid, and then on average, 8.6 statements are contained in each query. It means that we can generate many valid query, and then the query are complex. We also compare our approach to the state-of-the-art, specifically SQLsmith and Squirrel. We can find more bugs than them. In these 4 database systems, our approach, DynSQL, can find 29 bugs. However, they can only find 6 or 7 bugs respectively. And then we can find covers 41% more code than this database fuzzer. This is all about our approach. Let me conclude. It is very challenging and difficult to generate complex and valid queries. We solve this challenge by dynamically collect the database state information stored in the database system. And then we use this information, we propose dynamic query interaction and found 40 bugs in 6 database engines. That's all about this presentation. Thank you very much and welcome to any question.